Okay. So thank you for inviting me to this symposium. Like the last presenter, I am also BSSW fellow for this year. And similarly, like I'm working on a topic that is something to do with reproducibility. Uh, but more about like what I'm going to show about is like a problem that I have faced that is mostly like in HPC, that generally when we come from the Docker side, like what the issue we face. Uh, so here, so further, like I go on to this, and I'm going to show a because I'm working on another like platform that I use this thing to translate on HPC. So how it worked, like that will be the examples that I'm taking mostly in this one. So, here, in terms of like, so the first one is like why the reproducibility and replic uh, replicability is important. So that we see like as you all have said, like this become a burden for us, like in conference, like to check all the artifacts in like for their reproducibility. So yeah, there has to be some way to do the AI way or LLM way. So that is the question that trying to answer here. And one of the reason is because we are researchers. We are not, as you have said, like we are not DevOps like DevOps engineers. So so this is like a gap when we get into this space. So so how AI can help us? That is the question I'm trying to solve into the specific the Docker to Slurm area. So here, this I'm showing this is something like a suppose like if we have anything like a multi-service Docker. Uh, so that is like generally we have multiple containers or Docker image. Everything is doing some other. Everything have its own purpose, and we just do one command like Docker compose up and send it to background, and it works. But like, can we do this thing on HPC or Slurm? Because like we have things like Slurm is just a scheduler here. We don't have Docker Compose type of thing here. Uh, we do have containers, but like those are like Charlie Cloud or Apptainer, or there are some like Sifter or something, but like there are specific containers that we can use. So how we can fill the gap like here. So this is the thing that I'm trying to solve here. And here, this is like something, if we go into, like here, I have used the Charlie Cloud example. Uh, so suppose like we have something in Docker Compose, and the equal command that we can run in Charlie Cloud for different things like for the health check, for the like mounting the volume, uh, that type of, then we have like the DNS service port. Like service port is easy in Charlie Cloud or Apptainer because like the network service is not under it, it it uses the same network of the host. Uh, but there is something like in some issue with the GPU, finding the GPU. That is easy in Apptainer. Charlie Cloud is a bit new. That's why, but like the latest version that I find now, they have solved this. So these are the issues that we find that like, and still there is a solution. Like we can do it uh, with Slurm. So we just take it like more like a Slurm is the like Slurm is more like all the resource manager, and that is working as our what the Docker Compose does. So for example, like what I did is like suppose like we have this is for a platform that is like A3RD, that is like AI assisted archaeological remain detection. So this is more like we have satellite imagery. We use it to run we send the job to HPC cluster from there, and we have a raster imagery, like lots of things were there. But like if suppose if I want to run this thing on HPC, like on Slurm, uh, how we can do it? Like that is something like there is no simple like directly I can run this thing using Slurm. So there has to be the solution that is like I created the script for that, like, and that worked like as I expected. So that is what I'm showing here. So this is like 9 services that are there, and use like 7 translation tools. Uh, so, but that is like there is no LLM tool. So that is like I took the help from LLM, but this is a gap that we can fill. That is there agent like that could help us something into this area also. So here, this is like for example, I'm showing here uh, in Kubernetes, there the alternative path that is more mature than the Slurm way. Slurm has different purpose. That's why like that is. But like Kubernetes that can do it like that way, and it can run like suppose like for Chameleon like Kubernetes is the way to go. Like we can set up our own. There are different products here in this thing, like in this area that is like we have SkyPilot, and like this area is more mature. So we have things already set up in Kubernetes side. But in Slurm, we still need to do lots of manual thing in this area. So this is the area that I am working, that like how to do it like a more automated way, like anyone can use it in Slurm and PBS environment, whatever we can do with the Docker Compose or the any DevOps container. Uh, so here, this is showing more like Docker Compose, like suppose our test bed constraints, like how many like Slurm partitions are there, like these things we need to know about like before. GPU counts are there on each node, what are the module name, scratch part, and all those things like that we need to know. And then we need to use a type of like LLM translation agent that will be like that will provide us like all the how to translate totally into the SBatch script, or we can also use the Kubernetes way, like that is also like it could work if that is available there. Uh, so this is what I'm showing. Like this is a very much deterministic mapping. Like it has to be one-to-one mapping, and there are already 3 tools available in the Kubernetes area, but there is nothing available for the Slurm. And this is the niche area that to be explored and worked. So I did like something like it took me like 400 lines to just translate all those whatever Docker Compose was there into HPC testbed, but it worked that way. So based on that, like because like I find this topic is getting a bit more different than the reproducibility like that is discussed here, but still I will say like still like the volunteer, like we are like volunteer domain scientists, and we are forced to do the DevOps engineer work, like to evaluate artifacts. This is something like burden of translation that is still there. Uh, there is a tooling void that is like why like the Kubernetes area is much mature in this like in this part, but HPC Slurm, this is not like and who is responsible? And one of the reason is because Slurm or PBS was not built for this purpose. So that is one reason. But like we can fill the gap here, uh, and also like bit by bit, like container reproducibility. That like there are lots of issues that we get into when we go into this area, and also like there are lots of advantages as well. Like the inode, like that is mostly like exploited right now. Like people are just going with the conda and all those things, and every user is getting their own conda, and that is filling the HPC like everywhere. So this is like a this type of solution. Like if we go more, this is also more about like promoting more the container way to do things. So this is better infrastructure impact. And so that is like a the committee of like conference, like they have a standardized submission format or something rather than a specific platform. This is more general question for this symposium. Yeah. Uh, in terms of like, I have two more slides that is like that I kept more for something like what was the issue that comes into this area like that is. So this is like one of the issue that comes is the database. Mostly database like Postgres or any other database, generally they run as their own generic user. Like they always have a Postgres user, it runs. That is not possible with the Charlie Cloud, Apptainer, or any other rootless way. So there are rootless database already built. Like we just need to download and just run it, but we just need to have a practice of using the rootless, like a rootless database all the time. And that is like next one is these are the 7 translation that I use in my that while running on the HPC testbed. So so this is like a this is much more like a deterministic that I have said, like you have like first 4 are more first is like health check is something that we always do, like bind the path, the network, then the GPU if it is there, and GPU is mixed bag, like sometime there may be issues, sometime not. Then other 3 are more like how we restart and how we pass the environment variables and all. That is so. This is a type of like initial thing that I have prepared in this fellowship. I'm going to build upon this thing, and the that will be like more like I'm going to have more tutorials in this, like to train other users to use us and go into this area. And yeah, also like trying to arrange a workshop at SC. So that is like my plan. Yeah.
Thanks, Pong. This is fantastic. Um, I'll just open, since I can't see you, but I'll
Okay.
just open the floor for questions.
Yeah. Okay.
Questions.
I don't have any yet because I'm not familiar with the tech. I mostly use Zaptainer, but I definitely am aware of the problem. Docker doesn't work on derecho, for instance, so those kind of things. I think this is a really cool fellowship, and I'm excited to see what comes out of it. No questions, though. Sorry.
Oh no, so go.
Oh, no.
No, please go ahead.
Docker doesn't work over what?
On derecho, you need root access. So, derecho's in cars.
Nice.
Yeah, sorry.
Okay, you go.
Yeah, it's a great talk. I had a kind of a question about generalizing things. I have the feeling that this is very geared towards artifacts that run Docker and HPC. Have you thought about how this could generalize to more subdisciplines of computer science? And is this geared more towards, or are you thinking to gear this more towards principles, or a practical tool that is very focused on a particular sub community?
No, this is going to be for general, like whatever we can run on any DevOps, like any platform or anything like web. Generally, like these multi-service architecture, they have like something, you have a front end, you have a database, you have a back end. So these type of things could also be done on HPC as well, like 7 days, like you can run something and you can submit your job or those type of things as well, like directly from there. There is also a part of this that is like using the globus compute and globus stream type of thing. Like suppose if we want to have like something, this is a independent web server, and we want to submit job to HPC cluster anywhere. So how we can do it? Like it's not like just we submit a job. Like we also have to submit the data, and these like when we have satellite imagery or these type of things, training. So we have to send the data as well at the same time. So how we have like transfer the data, run the job, get the data back, like these type of things, how we can do it together. Like this is also part like if we are not doing inside the HPC, like if we are doing outside, then how we can have a streamlined workflow. So that this is more a applied thing that uh, I'm trying to solve or trying to build upon. Uh, but I feel like this could be used by DevOps uh, like any other
Right.
application here.
So, if I may follow up on
Yep.
what Bo was asking about, so here your objective is, that researchers are creating Docker containers, but they want to run on HPC, right? You want to transfer their workflow from single node Docker container to an HPC environment. And you have to do the translation. Now, I believe that is happening manually currently, like the way you're
Yeah.
showing the rules. Um, have you tried to train an agent based on those rules so far?
No, actually not. But this is totally doable thing. Yeah, yeah, I understand. Yeah.
Okay,
Uh,
it is doable, but it's not done yet. Is that what
it's
you're
not done
saying?
yet. Yeah, that is the
Uh,
area. Yeah.
okay, okay. Um, any other questions? Well, this was a great talk. This is absolutely relevant, and I think, yeah, I mean, the fact that we propose Docker as our checklists and artifact evaluation instead, like for SC and all that, we should be doing for Charlie Cloud, and actually we can have an agent which does the translation even if the reviewer has submitted Docker containers. So this is very relevant. Thank you so much.
Thank you. Thank you very much for inviting.
Okay, so let's thank the speaker. I think I want to take, we have just 8 minutes. The way we've been running it is letting everyone sort of speak, and I am not a good timekeeper. I sort of want to have one final thought, which is we talk about, or we've sort of had these notions about push button reproducibility, that hey, you should come and hit and sort of everything should reproduce. Do we think that we are going towards that vision with AI being in place, or actually as we are sort of talking about, human validation is needed? So complete push button is not possible even with this stage of AI, and we need, so where do we think that are we in terms of push button reproducibility? I mean, when we began the whole sort of reproducibility thing, we thought, oh well, containers, they can actually solve everything, or all we just need are environments management and maybe more sort of a little analysis of the results, that should be sufficient. But now, we're saying that no, the problem is much bigger. Are we sort of going towards the step of push button reproducibility? So Daniel, since you're the first, maybe.
Thank you. Yeah, I think one thing that I would like to see, so this is not like my field that I'm developing stuff, but one thing that I cannot help but think is that we need authors to be more responsible. We need this part to be like really important for them. So instead of like handing things to the AI, I think if we make that responsibility, or we give more credits to reproducibility, like not just the paper, but also the code that goes along. I know that this is a discussion that we've had forever in the field, but I think pushing that will be very important. So in that direction, I think I'm okay, or I will be okay. And I think it's going to happen because these models are improving so much. I mean, based on Victor's presentation, I think it was like 8 months ago, planning came out, which is like, I thought it was like 20 years ago. But I think these things are improving so much. So I think we'll have one button one push button reproducibility, but the human needs to be responsible. So it needs to like approve that in some form, just to give that they need to be liable in some way for that.
You think that the onus of that should still be there on the authors to actually enable push button reproducibility. They should be
they should like approve or like be responsible for it. It's a similar way that we treat authorship. Like the AI cannot be an author of a paper. I think it's just so important, the reproducibility aspect, that it should be kind of at the same level.
So my question on this actually is, how is AI helping here compared to, say, something like a GitHub runner, where we can do that same kind of scripting and have the push button testing? That's essentially what we're doing with the reproducibility, but we have something that's deterministic, that we don't have to put guardrails around to say, did this go and cheat or not, because it's deterministic.
Well, I think I would imagine like lots of the authors that I submitted to the conference you were describing actually wanted, I think they wanted the code to be reproducible immediately, but 50% of them are having trouble, or 50% of the time. So I think the authors, even with all their effort, they're still having problems. So I think the AI can help with that part. Like they're not able to make it reproducible, generalizable to be run on another environment. So that will be one possibility.
So they're not doing science.
I think that's science too. I think
not doing science. Computer science. Well, it's just, man, that kind of gets down to what's our standard of validity. And if they're doing something in their own environment, they can't describe it, but they take some result that they got that they're not quite sure how they got, and they're making claims about it. That's not science. And that's essentially what you're describing. So that's kind of, for me, where our standards need to come in. So now I don't want to, I want to keep on this topic, but I would actually derail this in a completely different direction and say we're trying to fix a symptom rather than the problem. The problem is how we do publishing, not how we do artifact evaluation. We should change how we do publishing so that we radically reduce the number of papers published, and instead focus on, you have to give me something that shows what your idea is and how it validates. And then somebody else can come in and look at that, and then only then, that's what the peer review process is actually artifact evaluation. That I know is a non-starter for a lot of reasons, but I'd like to put together a proposal for that and see if there's a way we can do that. But sticking
I agree. I agree. I think
is how do we get AI to actually help people do better work? Because if you're not at least reaching that point where you can generate the same result yourself a second time, then I don't know what you're reporting on paper.
I'll let Bo go. I'll keep that discussion over there, but let Bo go next.
So I think there are several aspects here, but how when you write a paper, there's a lot of things that get lost because we only can fit so much in 12 pages. Similar with the README for an artifact. And I think there are several tiers of reproducibility and standards that we should hold authors accountable for. If you as an author cannot reproduce your own results, well, they're in trouble, right? So I think that should be the first tier of checks. And I think AI can help with that in the sense that it can actually try to run on your own environment based on your instructions and identify gaps. Not necessarily gaps in your science, but gaps in your explanation. So, you're talking about changing the publishing model. I think we should go back to having longer appendices where you explain exactly every step if it doesn't fit in 12 pages. When we were preparing for artifact evaluation, we actually had undergrads do this step. Like we gave them what I wrote as a README and the paper, and I thought it was complete. And I said, well, can you follow this step by step and get to the same result on the same machine that I ran? And they would try, and then at some point they would get stuck. They would come back to me, and we would review the steps. And I figured out, okay, I forgot to actually write the step down. And we do this iterative process for a few weeks until we're reasonably happy that at least on my machine, a second person could have reproduce that. Now you can replace that undergrad with AI and let the undergrad do more science, and then you can take it one step further and say, well, give the committee this AI that will run, and the AI will identify the gaps that the committee will, of course, have to review. I don't think it scales to have, or I don't know. I don't know how to make sure that the AI doesn't cheat or doesn't, not it cheat, takes shortcuts, right?
Right.
So I think the role, yeah, so I think that's where human scientists, role would be. These tools that speed up the mechanical part of reviewing, and maybe with these tools and this speed up, instead of just doing peer review for the static text, you could incorporate parts of the artifact while you're taking the decision. If if the threshold of doing this is reduced to, let AI run for an hour, go have lunch, come back and get the report that you review, and then you ask the AI to go back to the third step and do third prime, and then go with four and go have a coffee or review another paper or whatever. If that is, if that workload is offloaded to AI, then I think reviewers would be more eager to incorporate artifacts into their review. Because I think the problem is the cost of the human cost and the time and the effort involved in reproducing these experiments. And for computer science, it's relatively simple because all these artifacts are neatly packed. But imagine for chemistry or physics or even something related to data science or numerical simulations, right? That could be next to impossible for a single reviewer to actually run everything. You need a lab. AI can lower that cost.
Thanks, Bogdan. Victor.
Yeah, so as a engineer that works closely with scientists, I think to touch on what your question was as well, often it's just a skill gap. Like there's a lot of my peers that are extremely talented in areas, but they don't know how to put together a GitHub Action workflow to achieve things. Like Porto would be able to do a lot of the stuff for publishing and make it reproducible in real time kind of thing. So those tools they're not aware of or they don't know how to use. So I think AI bridges the gap by giving them abilities to learn about the existence of these tools, as well as leverage them with much less expertise than would typically be needed to use them. And so they can ask AI to help them set up a GitHub workflow or GitHub Action workflow or some other means of making these accessible to others to reproduce. So.
Thanks. Jay, would you like to say something more about the publishing part?
For me, I look at the volume of papers. So like Tanu, I was also 1 year reproducibility co-chair for the supercomputing conference. And that's an impossible job because you have a lot of people with unique hardware that they can't give you access to, and their papers are demonstrating the capabilities of this unique hardware. Or they're running at scales that only 3 machines in the world are capable of achieving. Or my favorite one from the year I was doing it, it took us about a month to get the software all built and configured. Then they said, let it run for 1,000 hours, and then you'll see the patterns we're describing. And it's like, we just exhausted the entire review period. And those are the kinds of things that make me think that we're putting in checks that we're trying to make work, and we keep running into situations where they can't work. And I think it comes down to the publishing model itself that we're dealing with is breaking under the weight of the modern publishing speed, rather than us going back and looking at, well, when we had very few papers published a year because science was tiny, how could we handle this effectively? And trying to rethink from there as to how do we make a scalable system, because we never thought about building a scalable system. And artifact evaluation is something we need to do in the short term, but how do we fundamentally change what we're doing so we have a system that is scalable rather than trying to make a non-scalable system work at scale?
Thank you, Jay. Han, would you like to say a few words?
I will say like this is something like, in fact, like this is the same thing like I was also struggling. So I will say like since all the environment are so much heterogeneous, like and the skill set is there like it takes so much time to transfer or do things. So maybe the AI could be a compiler that is not doing the science, but is doing the other things for us, like reproducibility part, like translation and doing all other stuff, and we do the science. Yeah.
Okay. Thank you so much, and thank you, everyone. I think we should give ourselves an applause. I think the idea is that if we can come up with some theme which takes very disparate sort of thoughts we have, like models in some senses with respect to an real artifact sort of evaluation mechanisms, write a white paper on AI and reproducibility. That is essentially the idea. It would be great if you can share your slides with me, if that is possible, with some like disclaimers that this is under publication, or I promise I won't put it to ChatGPT. But try to come up with a theme with which we can start with, and that becomes the basis for a white paper after that, or maybe a published paper. Yeah, but to begin with, it some paper. Yeah.
That's great.
Okay. Thank you, everyone, and happy to discuss more.
Thank you.
Thank you.
Thank you. Thank you.
And thank you,
Yes.
Taro, for organizing all of this.
Yes.